In this video, we're going to look at internal resistance of a battery. Internal resistance of a cell or a battery is the resistance against the flow of current or the flow of charge carrier due to the chemical constituents inside the cell or the battery. This causes the charge to dissipate some electrical energy as it passes through the cell. It will be turned into thermal energy. So remember the fact that when there is resistance, there will be energy lost due to that. So inside wires we have resistance, inside a resistor we have resistance. So this is the thing that cause the electrical potential energy to be changed into thermal energy or other forms. So thus the cell gets warm as it delivers current. I'm sure you notice that your handphones will get hot once you overuse it or use it for a long time. You have others electronics that uses battery. As you touch it after you use it for a long time, it will get hot a bit. So once we understand this, and now we look at as current or charge flows through a circuit, a complete circuit, it will gain electrical energy on as it passes through the cell, and it will dissipate this energy as it passes through the rest of the circuit. So we have a supply in the battery, and as it flow past the resistor, the lamp, or any other components around the circuit outside the battery, it will lose its energy. So from the conservation of energy, we can write in such that EMF of a cell is the total PD across the external resistor VR and the potential difference across the internal resistance. So this EMF that provides the energy, the chemical energy, it will be dissipated at the resistors outside and also its internal resistance. So in terms of per unit charge, that will be EMF equal to VR plus V small r. Small r indicate the internal resistance in the battery. Okay, so typical diagram is that you have the battery and the internal resistance covered by a box or a dotted line box. So that small r there is a typical symbol used for internal resistance. Okay, so that's another name for this VR, as in the PD of the external components outside the battery. So because it is at the two terminals of the battery, so we call it the terminal potential difference. Everything outside the two terminal of the battery. So let's say we have another resistor here, we have another resistor here. So the total PD across all this, that will give you the terminal potential difference. Let's say this one takes 2 volt, this one take 2 volt, this one take 2 volt, this one take 5 volt, and this one take 5 volt. So if we total this 2, 2, 2, 5, 5, that will give us 16 volt. So the terminal potential difference, according to the values that I give an example, is 16 volts. So by now you may be wondering how we actually know that there is internal resistance other than the heating effect. So let's look at one case here where you can notice the value of the EMF. That is when you have this circuit here, as you have the battery and the internal resistance R. Okay, and then outside you have a resistor and you have an ammeter in series and you have a voltmeter. So when the switch is open, that means it's not in contact yet. The voltmeter connect across the terminals of the battery, reads the EMF of the battery. Okay, that will be the EMF values. Then So then when the switch is closed, the voltmeter will read the terminal PD. Okay, when this is in contact, it will read this one here, it will read the terminal PD, PDT. Okay, so terminal PD, and the value will be usually a bit lower than the EMF. So let's say you notice that here is a 9 volt. Okay, and then when you close the switch, you will notice that it might have dropped to 8.5 volts. So the 8.5 volt represent the PD that is across everything outside the battery. This is 8.5 volt. And the internal resistance, we can deduce that it had already taken 8 minus 9 minus 8.5, that is 0.5 volt of the PD, of the EMF. Alright, so this difference in the volts, which is the 0.5 V, we say that it is the volts lost in the internal resistance. So notice this word, it is always used in the exams. So that is the volts lost. Alright, let's look at one example here. If we have a current of 0.5 flows from battery of 3 volt, so this is the EMF, 3 volt, and internal resistance of 4 ohm. What is the terminal PD? Okay, what is the terminal PD? That means the PD for everything outside the battery. Okay, so that means the EMF minus of the PD taken by the internal resistance, you get the rest of it. Solution. So we have terminal PD is E minus VR. So this is the PD taken by the internal resistance. This is the 3 volt of the EMF. So we have IR, because we don't have the PD given directly, so we change it into I times R according to Ohm's law. So IR, current 0.5, and the internal resistance is 4, and therefore we will get the 1.0 volt as the terminal. We'll look at another example. The circuit I have drawn up here, you can refer to that. The battery has an EMF of 1.5 volt and its terminal PD is 1.25. Okay, that means there will be some potential difference taken by the internal resistance I draw with small r here, and there's a resistance of 25 ohm. Calculate the current flowing and the internal resistance R. So the current flowing, what we can do is that, okay, we can use I equals to V over R, because the 1.25 is the terminal potential difference. That's a PD across the 25 ohm. So once we divide by the 25, we will get the current, that is the 0.05 ampere. And to get the internal resistance, what we can do is that we find the PD across the internal resistance. So how to do that? That is by minusing the terminal potential difference from the EMF. So 1.5 minus 1.25, that's the terminal, that's the potential difference across the internal resistance. And therefore, when you divide by the current that is calculated just now, you will get the internal resistance 5 ohm. Okay, so in order to, sorry, let's go back to the question. In order to calculate the terminal PD when the 10 ohm resistor is replace the 25 ohm, so this one is replaced. So bear in mind that now the current has changed. You cannot use the current that you have found in A to proceed with this. So what you can do is that we have the E divided by total resistance. Okay, the EMF divided by the total resistance, so that we can calculate the new current. So the new current, we can see that it has changed to 0.1 ampere compared to 0.05 ampere, so we cannot use the same current. Yeah, so proceed with this new current. What we can do is that, again, we use the terminal PD, that is the we find the new terminal PD by using the new current as it passed through the 10 ohm. Okay, so as it passed through the 10 ohm, because now the 10 ohm is the resistor outside the battery that takes all the PD outside. So we have 0.1 the current IR, then we get 1 volt. Okay, let's get 1 volt. That means now 0.5 volt is for the PD caused by the internal resistance. Sorry, internal resistance. Okay, that's 0.5. All right, so next question will be your assignment questions. Okay, I'm going to show you the answer first. You try to do that and submit through the Google Classroom. Yeah. Okay, I'll see you in the next video.